Hey kids, welcome back to Mr. Murray's Mathland. Just talking today about how to use the graphing calculator to help solve equations, and we're going to do this two different ways. First method, number one, is by using the zeros feature, so finding the zeros of the function. So step one, if you're going to use zeros, is to bring everything to one side of the equation to make it equal to 0. So subtract this from each side, and you'll have one new equation, which will be 1.5 ln of x minus 15 minus 2.5 cosine squared x equals 0. Okay, so now what I'm going to do is I'm going to use my graphing calculator to graph this as my y1, and I'm going to use the 0 feature to find when does it equal 0. Okay, so I'm going through this as if you have very little familiarity with the graphing calculator, so you may have gotten one last year and already be comfortable with the graphing features, but the purpose here is to try to show some of the features that you might not be that familiar with. So for graphing purposes, obviously press on first, and most of the graphing buttons you need are near the top here in this top row. So you go to y equals, and then I'm going to put in this equation, 1.5 ln, the ln button is right here, natural log of the quantity x, and the variable you always use is don't use the alpha feature, use this button right here, the x comma t comma theta comma n. This is always the variable you're using, x minus 15, close that set of parentheses, minus 2.5 cosine. Now here's the issue, and cosine squared of x means you're squaring the cosine of x, not the x, not the argument, not the angle. So be sure to close that set of parentheses, and actually if you put the squared, or you can use the exponent button, either one, that actually tells the calculator, since it's outside the parentheses, that you're squaring the cosine of x. However, if you're a little nervous, you could always put an extra set of parentheses around cosine of x itself. And here's another little feature here that a lot of people are not sometimes familiar with, and it's a time saver. Rather than retyping everything from this spot, if you want to insert a parenthesis right there, insert is right here, the opposite of delete. So insert, there we go, and then you can go to the end, and then I'll insert a second one, insert before the squared, and there we go. So now it knows that's being squared. And I'm just going to hit graph to see what happens. Now, little surprise to me, we don't see anything, because, well, there's two things to consider. One, you can turn the trace on. This trace is a little feature that goes on the graph, and it tells you where you're at. This tells you the equation you're on, and this says when x equals 0, the graph does not exist, is undefined. So you can either just scroll left and right using the arrows and hope you get to a spot where the graph is defined. You can also use the zoom feature to zoom out. So zoom here at the top. You can hit zoom out, and for whatever reason you have to hit that enter again once you come back. And then you see a little something there. It's over there. But I'm going to say, never throw out your math knowledge, your common sense when you're doing these things. Technology is just here to help you. It's a tool. Looking at this here, the natural log of x minus 15, you should know that a logarithm is undefined when the argument is 0 or negative. So x minus 15 has to be greater than 0, or in other words, x must be greater than 15. That's the domain of this function. So the graph doesn't even start until you get to x equals 15. So, rather than zooming out, which you do sometimes to get an idea, but it's look at it, it's kind of ugly looking. I like to set the windows to exactly what I want to be. So I'm trying to, kind of incorporate all these buttons a little bit here to show you. So my window here, if I know the graph doesn't even start until I get to 15, and actually there's a vertical asymptote there, maybe I'll put something just a little bit before 15, like 14. An X max of 42. I mean, maybe that's okay, but it didn't really seem like I needed my Y mins and maxes to be negative 40 and 40. I mean, you might remember some things about your amplitude of trig functions, being 2.5, that there, but let's just even go negative 6 to 6. Seemed like everything was pretty close to the x-axis. And there you see, there's your graph. Cool, it's got that sort of periodic feature, but because it's being combined with that ln, it's slowly increasing. Pretty cool. And it's really just going to go up from there and there. And we're trying to find when does this equal 0, or where did it hit the x-axis. And you can see it crosses the x-axis a couple times. 1, 2, 3, maybe even right there. Maybe a fourth time it hits it. So just to really zoom in here, again, you can use zoom and zoom in, or I can really set the windows a little tighter. Seemed like everything happened within 5 or 6 units of there, so 21. Maybe I don't really even need all this. There's 1, 2, 3. And maybe I should have gone a little bit further to the right. I should be able to get a better picture here, so you can tell if it does in fact cross the x-axis. And there you go. Now you can see it definitely doesn't. And that's an important feature with the calculator, is being able to see what's going on. Sometimes it's too crammed together with these pixels. You can't even tell what's happening. So I'm pretty confident that this function only has 3 zeros, or 3 solutions. So it doesn't matter which one you find first. So I'm just going to say focus on finding this one, this leftmost one. So when you want to calculate things, zeros in this case, this is the second trace right here. We'll bring up the menu, calculate. So second trace, and item 2, 0. So I'm going to either hit 2 or scroll down. Now it's asking you for a left bound. Now whatever one you want to find, now I said I wanted to find this one. There's the trace. You want that to be to the left of the 0 you want to find. So one thing I can do is I can just keep scrolling to the left until you are definitely to the left of that target 0, and then hit enter. Now it's going to say right bound. Well, now you want to push it somewhere to the right of that 0. So I definitely push it to the right, and you hit enter. And now you've given it a little window to search within for where it crosses. So hit enter for the guess. I'll talk about what the guess could be for in a moment, and there you go. There's one of the solutions, and you see that when x is this value, y is this, and that's scientific notation for being super close to 0, which is telling you it's 0. So I'm going to write that solution down. This is AP, so we are saying this equals 0 for x approximately. Always must be accurate to 3 decimal places in AP, so 16.68. That does round to 5, but in AP you can either truncate, which means just you can answer with a 4, or round to the closest one, which would be 5. But it's got to be 3 places after the decimal. All right, so now, but I got 2 more solutions to find here, so we just redo the same process. Second trace, 0, and now left bound, right bound. So left bound, right bound, and the guess feature would be, by the way, if you set like a really broad window and there were multiple zeros happening in that window, you would have maybe tell it an x value that it would find the 0 closest to that x value. But if you've set a good window, there's only 1 in there, so you just hit enter. It's going to give you the one closest to where you're at. And so our other solution is 18.285, or 0.284 if you like to truncate. I like to round, but it does not matter. Now I'm going to get this second one, and I'll talk about the other way you can do this when you do second trace 0. If it's ever annoying to scroll, it's not too bad here. We're pretty close to the next one. But this left bound, you can also type the value. So I could type 18.6 is certainly to the left of that 0. It looks like it's a little bit more than 19. My right bound is, you can even just say 20. It's definitely somewhere between 8.6 and 20. So hit enter, 19.226. And there we go. 3 solutions, good to go. I don't think you want to try to solve that one algebraically, but there you go. So let's talk about the second method, which is actually, I think, the better one, the better of the two, but it's good to be comfortable with both features because, believe it or not, sometimes one just works better than the other. You know, technology is not perfect. So we're talking about where does this equal this. If I were doing zeros, I'd bring it all to one side, but I'm doing this one by finding intersections, which means I'm going to graph two separate functions. I'm going to graph the left side as y1 in my calculator, and I'm going to graph the right side as y2, and I'm going to see, well, where does this equal this? Where do they intersect? So I'm going to go back to y equals. I'm going to clear out that function I was just using. 1 over x plus 3 minus 0.5, so 1 over. Now I'm going to do something that a lot of you would do, and it would be wrong. Hopefully you wouldn't do it, excuse me. X plus 3 minus 0.5. Do you see the problem with this? The problem is that you didn't, or I didn't put parentheses around the denominator, so the calculator is going to think that only x is the denominator, and then it's going to add 3 after the fraction. So to do this, you have to remember to use parentheses, and now it tells it, oh, okay, x plus 3 is that entire denominator. However, clear it out just to also show you this feature. If you'd like to make a nice fraction, which is a really nice thing to know how to do because you're going to put in some complicated things this year, there is a fraction button where you can enter it as a fraction as it looks on paper. It's in the F1 menu, so that's in green, so I hit alpha y equals. Alpha y equals brings you to this F1, and the very first thing is n over d, and you see it makes a nice little fraction there, so you don't have to worry about did I use parentheses, you know, in the right spot or what. There you go. And now I'm going to go down to y2. I'm going to graph this function, and again I intentionally brought in some funky functions here to let you know where they're at on the calculator. First thing is absolute values. Absolute values, along with a lot of other random things, are in the math menu. But even in the math menu, there are several columns. So we go to math and scroll to the right, and that's number. The number column has absolute value there, abs. So bring that, and it brings those nice absolute values. Now I need the cube root. Cube root, as well as all other higher roots besides square root. Square root is on the face of the calculator, but cube root and higher roots are in the math menu. So math, you may have seen it when we were here just a second ago. There's the cube root, and there's the x root for fourth roots, fifth roots, etc. Cube root of x plus 10. Get out of that when you're under that, you know, that radical. Get out of the radical, make sure your cursor's out. Minus e to the x. E to the x, that's the inverse of ln, so second ln x. And then make sure you're after minus sine of x. I like to close that little argument. You should. Good habit. And I didn't actually mention it, but anytime you're using trig functions, you do have to worry about what mode should your calculator be in. Particularly if you're coming from physics class, you're probably in degree mode a lot. But in calculus, everything, always, you're in radian mode. So you don't need to ask, you're always in radians in calculus. So there's something to be aware of, and that's in mode here. And you can see radian is highlighted, so we're good to go. I should have mentioned it on the last problem since we used cosine, but whatever. Now if I hit graph, I get this. Great, what was that? Nice. But remember we had the windows all set up for that very particular problem last time, so that's going to happen frequently. If you go to the zoom, zoom standard always puts you back to that negative 10 to 10, you know, if you're not sure, you know, where you want to be, but let's just get a good sort of standard viewing window. Zoom 6, and you can see, hopefully you recognize that hyperbola function. That's the 1 over x plus 3 minus 0.5. Notice the vertical asymptote at x equals negative 3, where this fraction is undefined, and a horizontal asymptote at y equals negative 0.5. And then you've got this absolute value of cube root, funky curve right there. and I've got to determine how many times do these two things intersect. So I definitely can see them intersect here, and it looks like here, maybe there, I'm not sure. And you also have to check, it looks like they could be intersecting over here to the left. So another couple things here about graphing in general. When you turn on the trace here, it tells you, especially this is helpful when you have more than one function graphed at the same time. Now if you have the nice new calculator, it'll graph with different colors. I'm using kind of a slightly older model here, which I'm sure a lot of you will be using. And the trace is helpful. You bring that up and it tells you what graph you're on. And so I'm on the first graph, Y1, and as you push around just left to right, it tells you, hey, these are x and y values that correspond to that function. You can also tell it where to go. If you want to say when x is -5, just type -5, and it'll go there. On this graph, when x is -5, y is -1. If you want to switch to the other graph, just press up or down, and that's sort of, just imagine you're scrolling through that inventory in the y equals menu there. And so now you're on y2, and if you want to type, x is -5, well, there's the y value on that one when x is -5. So that's helpful to distinguish between the two graphs if you're not, 100% sure what shape is which, and you don't have colors to differentiate. So a couple things here. One, let's go get this one right here. This is easy to see. They intersect, so we're going to calculate an intersection, not a 0 this time. So it's the same menu, second trace, calculate menu, and that's item 5, intersect. Now, this will always go to the closest intersection to wherever your trace is. We're right there, so I imagine it's going to go to there. First curve is this one, so you just hit enter. Second curve is this one, hit enter. Guess, again, you could just hit enter and it'll go to the closest one. If you want to say, hey, I want to go to the one that's around -3, this is where you could type -3 if you like. And apparently that's an issue. So I'm going to go back to my graph. I'm not sure what the problem was, but let's see. Sometimes you need to have a better view of the intersection. I'm going to hit trace. I'm going to turn this trace back on. Oh, I know what it was, because I told it near -3, and -3 is not in the domain. Haha. See, troubleshooting, even, I can make stupid mistakes. So second trace, intersect, enter, enter, enter. It goes to the closest one, which is about at x equals -2.649 if I round, and the x value is what I'm looking for here. There might be times when I care about the y value, but not in this case. I'm looking for the x values that make this equation true. So x is approximately, and if I don't make the approximately symbol, that's okay. Sometimes people ask that, will graders care? No, they consider them the same. It's a nice habit to be in, though. So x is approximately -2.649. That's one solution. And now I really want to get a better view of what's happening here and really over there. So I'm going to set my windows. It was somewhere between -1 and 5 on the x-axis, and the y values were pretty small also. Maybe I'll go -3 to 3. Again, you could push the trace over in that neighborhood and just zoom in. And now you see there, actually it dips below. There's that graph approaching the horizontal asymptote, and this dips below and intersects twice. So second trace, intersect, enter, enter, enter. It's going to go to the closest one, which would be that one, I would imagine. And x is about 1.043. So 1.043. And now I'm going to get to that other one. So I'm going to redo second trace, intersect, enter, enter. Before I hit enter the third time, I'll just either type an x value or push my trace. So it's definitely closest to this one. And hit enter, though. You got to actually hit enter so it goes there. Just because it looks like the trace is right on it doesn't mean it is until it tells you. Intersection at about 0.613. 0.613. And if you remember here, zoom standard, it looked like there could be another intersection over here. And, this isn't an easy equation to know, like, hey, They should intersect. They might intersect 3 more times over on the left. So let's check the window. The other thing with the trace, if you don't want to set the window, is if you go to -9, you can just scroll and it'll push the window right along with you. Sometimes this can be time consuming if you want to see, like if you want to know, I want to see all the way to -40, you don't want to have to scroll there. It really looks like they're never going to intersect. Let's get a good view. I know that first graph is going to be hovering right around y equals -0.5 because that's the horizontal asymptote. Again, that's at least using your knowledge of functions here to give you a little faith in what you're looking at. And yeah, you can see there it got kind of close right at that edge, but then it actually veers away and it's never going to come back. So if you don't believe it, you can keep scrolling out and make sure it doesn't come back down. But that's it. So we had only 3 solutions to that. And hopefully I was able to show you a few tricks and pitfalls to avoid, even ones I make. So things happen with these even after you've been using them a long time. It can be frustrating sometimes, but that's that. And it is nice to note that this is very easy to do on Desmos, easier than the calculator, because you type in this, Desmos is very user friendly. When you go look at the graphs, there's already the intersections plotted for you, and you just click on them and boom, there it is. But unfortunately you can't use Desmos. You got to use this on the AP exam. So good to know how to use this. I mean, a lot better than trying to do it by hand, which is what we did back in the day, kids. So hopefully you picked up a few things, and if you got any questions, as always, just let me know.